आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़।
Celebrating Azadi Ka Amrit Mahotsav, we bring you a podcast series on STEM popularization, science, technology, engineering, mathematics and medicine, supported and catalyzed by the National Council for Science and Technology Communication, Government of India. This program is produced by Media for Community Foundation. Creative content and technical support is given by Purvasha Banerjee and Shushanto Das.
एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़, की आवाज़, की आवाज़।
Indian Statistical Institute is a public university which is recognized as an institute of national importance. It grew out of the statistical laboratory set up by Prashanto Chandra Mohanlanobish in Presidency College, Kolkata. Established in 1931, this unique institution of India is one of the oldest institutions focused on statistics. Primary activities of ISI are research and training of statistics, development of theoretical statistics and its applications in various natural and social sciences. We welcome Dr. Pradip Bhattacharyya. Sir is an associate professor working at the Agricultural Ecological Research Unit, Biological Sciences Division in Indian Statistical Institute, Giridih. In this episode, Sir shares about his work in this field of research, about various collaborations and implications of the research work.
This is Pradip Bhattacharyya, Associate Professor working in the Agricultural Ecological Research Unit, Biological Science Division, Indian Statistical Institute, Giridih, Jharkhand. My research area generally focused on the environmental pollution, remediation thing, and also the climate change. Now, we are using each and every day the water for drinking purpose. Now, in the Jharkhand, there is a land of mines, and there are various mines located in the Jharkhand, like mica mines, like chromium mines, like iron mines, like copper mines, bauxite mines, etc. And that during the excavation, the mine tailings generated, and it's due to the runoff and the wind problem, and this tailings contaminated the nearby agricultural land and also the water bodies. Now, water bodies over there, it's contaminated with lots of metals like arsenic, like fluoride, like copper, like chromium, so on. So, this arsenic concentration in the WHO limit for the drinking water purpose for the human being, it's a 10 ppb, that is 10 microgram per liter. And also the fluoride WHO limit is 1.5 ppm, that is 1.5 milligram per liter. Now, the area in the mines area over there, it's a groundwater, its fluoride concentration over there, sometimes it goes above the 15 ppm, so about 10 times higher compared to the WHO limit. And also the arsenic concentration in the drinking water, it's above the 200 ppb, so it's a 20 times higher compared to the drinking water limit set by the WHO. Now, peoples are knowingly or unknowingly, they are taking they are taking this contaminated water for their drinking purpose. Even they don't know also. So we are actually making some filter over there. Now filter, what is the uniqueness of our filter? Now generally the filters available in the market, that is actually the chemical based. So chemical based any compound. So I did some research work in the copper oxide nanoparticle or any nanoparticle like copper oxide or alumina oxide or iron oxide. It can remove easily the fluoride and iron and other trace element. When that clogged, then we have simply dumped that thing to the nearby soil. Then we change the filter. Now again, that soil is getting contaminated by that particular arsenic or the fluoride or the nickel. Now our filter is actually the plant based. What is the plant based? Now the agricultural waste like water hyacinth, like corn cob, like sugarcane bagasse, like rice straw. So we are making them as a biochar. What is biochar? Now biochar is the in absence of oxygen or partial presence of oxygen. When we convert that agricultural waste, then it's simply converted to the black color biochar. So it contains lots of carbon and it contains lots of pore space. And that pore space is responsible for the metal adsorption. So when we'll use that biochar or the chemically activated biochar, then the biochar can absorb the arsenic, fluorine, nickel, etc. into its body. Now, when it is clogged, then what we will do? Because the story is same over here. The chemically nanoparticle and the biochar already clogged. Now, as this is a plant sample, so we can use that biochar with the help of the cow dung and the vermicompost with the earthworm to make it as a vermicompost. So vermicompost, when we will do that vermicompost, all the metals present in the biochar that is already clogged in the biochar, that simply reacts with the protein content in the earthworm guts, and when the excreta comes out, which is known as the vermicompost, the metal will be in the locked condition. So that means the metal is no longer available for the plant, not for the microorganisms. So when we have applied that vermicompost, that is the biochar vermicompost, to the crop as the organic amendment, there is no metal uptake in the edible part of the crop, whether it is rice, whether it is mustard, whether it is vegetable crop. So we have already done that thing, this kind of research, and the student already got the doctorate degree. We have published that paper in the very good journal like Science of the Total Environment, like Environmental Research. So this is a very good journal because their impact factor is more than 8 in the Elsevier Science. And this is a holistic type of research because farmers, we have already transferred that technique to the farmers. So farmers use that their rice straw, and whatever the rice straw they have, whatever the sugarcane bagasse they have, so they can easily done that they have easily convert that thing to the biochar, and when that they pass that contaminated with that biochar, that metal already clogged in the biochar, and they can simply use that biochar with the help of the cow dung and the earthworm to the vermicompost, and they can use that vermicompost to the crop for the organic cultivation. So this is the waste to wealth, or you can say this is a simply a holistic approach to solve the water pollution problem. Also, the soil solution, soil contamination problem in the mine area zone, the soil is contaminated full of trace element like chromium, like nickel, like aluminum, etc., etc. We already did that research that we have isolated the metal tolerant nitrogen fixer, phosphate solubilizer, potassium solubilizer, microorganisms from that area, and we have done the biofertilizer from that microorganisms. Because you know that the people, generally for the crop cultivation, we need nitrogen, phosphorus and potassium fertilizer. For the nitrogen, we generally use the urea. For the phosphorus, we generally use the single superphosphate, and people use the muriate of potash for the potassium. Now, people are generally reluctant to add muriate of potash as this is imported and the cost is much more higher. So, the potassium soil is simply a lack of potassium. Now, if we'll add the potassium solubilizing bacteria over there, and the Jharkhand, one of the mines area over there is the mica mines area. In the Giridih, and Giridih district is one of the biggest reservoir or the largest reservoir of the mica in India. So mica, it's a potassium aluminosilicate. It contains 16% of potassium in the locked condition. So we have isolated the potassium solubilizer from that area, and with the help of the potassium solubilizer, and also that if we will use that mica tailings, so simply that potassium solubilizer solubilize the potassium and it can supply the potassium to the plant. So that biofertilizer already we have supplied to the farmers, and we have already made some farmers training program regarding that. Farmers already using that thing, and that technology is a very cost effective, and cost effective means its a cost is much more lower compared to the available biofertilizer in the market. So this use of this biofertilizer and the vermicompost, not only this is the organic cultivation, but it will also help the soil health problem. In our Honorable PM, in his first budget lecture, he emphasized on the soil health. So we are actually doing this thing very sophisticated way over there. We have already transferred our technology, whatever we are doing in the laboratory, to the local farmers, in the mines area farmers, and also the local farmers. They are simply using that thing, and their yield is very good, and also this is organically produced thing. Now, mainly in India and the world science, the many people are using or they have already invented some filter with the chemically produced thing like nanoparticle like copper oxide, aluminum oxide, but nobody care about that. After getting its clogged, what will happen? So this is the uniqueness, novelty of the research, that we have converted, that we have already simply make a filter, and that filter, when this is clogged, we have converted the vermicompost, and people are using that thing vermicompost for a organic cultivation. So this is the novelty of the research, and this research already collaborated with the different universities like Salford University, UK, and also the Stephen Institute of Technology and Michigan Technological University, and also the Dakota State, so in the United States. And we have already published that paper in the Groundwater for Sustainable Development. We have published that paper in the Chemosphere, Environmental Research, Journal of Cleaner Production, Science of the Total Environment. So all the impact factor of the journal is about more than 8 and more than 9. And we are planning to patent that our technology. So basically this is the people's research, because the people can use that technology very easily. So if we'll train that thing, so they can easily use that thing, so they can solve their own problem. Thank you very much.
We thank Professor for sharing his knowledge and experience and enriching us today about how we can turn waste into wealth.